this video, we're going to look at some complex logical terms. So they're connectives that in English are expressed using just a couple of words, typically. And in SL, we don't have individual connectives to represent these. We use combinations of connectives for these. So first one will be neither nor. So neither P nor Q, what this means is that both P and Q are false. So here's the characteristic truth table for it. It's going to be true when both P and Q are false, and it's false otherwise. Um, so here's an example, right? Neither May nor Blanchet will win the next federal election. This is Elizabeth May. She's a leader of the Green Party. They get like anywhere between 3 and 6% of the vote overall. This is Yves-Francois Blanchet. He's the leader of the Bloc Québécois. They don't run candidates outside of Quebec. Neither of these people is going to become the next prime minister. So this sentence is going to be true. So how would we symbolize this in SL? Um, First way that you can do it, look at the truth table for P or Q. You can just notice, right, that the truth values in all of these rows are the opposite of each other, right? P or Q is true every time this is false, and it's false in the one case where this is true. So you can get this by just flipping the values for this. And we can flip the values for this by just taking this and negating it. So if you want to symbolize neither P nor Q, what you can do is you can take P or Q and then just negate the entire thing. So for neither May nor Blanchet will win, right? What we can have is this, not M or B, right? And here's the paraphrase that you would use. The second way of doing it is this. You look at this and notice, so this is true only when both of these are false. So the other thing that you can do is you can just write a sentence that says P is false and Q is false. And that sentence just looks like this, right? For neither May nor Blanchet will win, you just have not M, May won't win, and not B, Blanchet won't win. And that's equivalent to the first symbolization that we have, and they're both equally good ways of symbolizing neither. The next one we'll look at is not both. So not both P and Q, what this means is at least one of P is and at least one of P and Q is false. So if they're both true, it's going to be false. And then in either one or any of these other three possibilities, it's true. So for example, Trudeau and Poilievre will not both win. That's Trudeau. You've seen him already. This is Pierre Poilievre. He's the leader of the Conservative Party. He used to wear glasses, but now he stopped wearing glasses in order to look less nerdy. Uh, as a logic instructor, I have to strenuously object to somebody trying to look less nerdy. We're very firmly opposed to that in this discipline. So if you want to symbolize this, first thing you can do, right, or first way you can do it, right, look at the truth table for P and Q, right? This has the opposite truth values for not both P and Q. So you can do kind of the same thing we were doing with the last one, right? You symbolize this by you take this and then you negate it in order to flip the truth values around. In order to take this true, make it false, and these falses make them true. So you would symbolize this sentence like this, right? Not TNP, right? It is not the case that both Trudeau will win and Poilievre will win. The second way to do it is if you look at the truth value or the truth, yeah, the truth tables over here, right? You notice so this is true whenever one of them is false. So we could say this either P is false, that's one of the things that will make it true, or Q is false. That's one of the things that will make it true, or both, right? So we're going to use an inclusive for this. That gives us this symbolization. Either it's not the case that Trudeau will win, or it's not the case that Poilievre will win. So not T or not P. Third one we'll look at is exclusive. When this is This is actually you, or you have like a special connective for this. It's referred to as XOR, right, for exclusive OR. This is the truth table for it. So it is true when exactly one of the disjuncts is true, and it's false if they're both true or both false. Um, so first way you can symbolize this is you start with P or Q, right? Your inclusive OR, which is true when both of them are true. And then you just rule out this possibility, which you can actually do with with not both, right? So what you say is basically just P or Q inclusive, and you can't have both of them being true. So for you can have coffee or tea. Remember, we talked about this in a previous video as an example of a use of an exclusive or in English, right? You could symbolize this like this. You can have coffee or tea, and you can't have both. It's not the case that you can have both coffee or tea. And given, remember that this is just not both here. So you could actually symbolize this as either you could do it this way, or you could have it as C or T and right. It's not the case that C and or sorry, it's not the case that C or is not the case that T. Right. You could use either of the ways of symbolizing, uh, not both. The other thing that you can do, you can use this truth value flipping method that we used for the other ones as well. So here, what you'd be flipping is P if and only if Q, right? This is true when they're both true or both false. So its truth values are the opposite of XOR's. So you can get XOR by just negating this. This is a much shorter way of symbolizing it, right? Much simpler, right? To symbolize XOR here, you just have it is not the case that you can have coffee if and only if you can have tea. So it's a much simpler way of doing it. It's less intuitive though, right? Like the previous one is easier to understand, right? You can have coffee or tea and you can't have both. This one is less intuitive, but far simpler once you get used to it. Last connective that we'll look at is unless. So, for example, your plants will die unless you water them. Here it's easiest to think about it more generally than looking at a truth table for it, right? To say P unless Q is basically to say that if Q doesn't happen, then P will. So your plants will die unless you water them. The sort of intuitive way to symbolize this would be like this. If it's not the case that you water your plants, if you don't water your plants, then your plants are going to die. So you would get this as your symbolization, not W implies D. Now this is actually equivalent to or. And we'll see this later on in the course, but that that formulation, the way that we put that up, is actually equivalent to saying this: either your plants will die, or you water your plants. This is inclusive, and note that it is actually the original sentence, right? Your plants will die unless you water them. It actually allows for the possibility of both, right? You could be watering your plants, and then you knock over the pot, and the pot breaks, and the plant dies because of that. So it's possible that both of them would end up being true. Um, this is um, this is the preferred way of symbolizing unless is to do it as or. Um, it's simpler that way. Um, it's less intuitive, right? People generally find the previous way of doing it more intuitive. It gets complicated though when you have particularly if you have a sentence like this where one of the components of the unless is itself negated, right? So take you can use the gym unless you're not a member. If you go with the first way that we had of symbolizing it, it's going to be this. If it is not the case that it is not the case that you are a member, then you can use the gym, right? You have to add a negation when you put it in front of the conditional, and it's already got a negation in it. So you're going to end up with two there. And this is where people like very, very frequently mess this up. They either forget to add well, typically what it is that they forget to add the negation. Um, It's a lot simpler if you just do it like this, because then you just symbolize each of the components separately and then you replace the unless with or. So it avoids a lot of confusion if you do it, if you just treat unless as or, despite the fact that many people just find that very weird and and counterintuitive. So these are a bunch of very common truth functional operators that you get, and this is how you would symbolize them in SL.